Welcome back, guys. Today I'll be doing solving differential equation, which is not exact. Let's get started. Here we have the differential equation e to the x plus y minus y dx plus x times e to the x plus y plus 1 dy is equal to 0. Now here we're going to solve this differential equation, and I am going to rewrite the differential equation. This is the general form for the differential equation mxy dx plus nxy dy. The first bracket represents mxy and the second bracket represents nxy. Now I'm going to differentiate mxy with respect to y, treating x as a constant. To differentiate y, because when I differentiate x, that's 0. So differentiating y, it would be 1. So I will get e to the x plus y. Now differentiating y, that's 1. So I'll have minus 1. The next part, I'm going to differentiate with respect to x. So I have to use product rule. Differentiating 1 is 0. But product rule, I differentiate x, I will get 1. Then I leave e to the x plus y alone. Then I differentiate e to the x plus y. Remember, I stated that differentiate x, I'll get 1. You'd have put it in front. So you would have gotten back e to the x plus y. So I have here x, e to the x plus y. I repeat, product rule. Assign this to be u and this to be v. So differentiating u, I'll get 1. So there will be a 1 here. And we leave v alone. So here, this is v. Leaving u alone right here. Then you differentiate v. Differentiating e to the x plus y, I will just get e to the x plus y. So this is just applying product rule. Now this is not exact since my is not equal to nx. So what I will have to do is find an integrating factor. In order to do that, this is what I need to do. I need to have my minus nx all over nxy. So substituting the information I have here, my, this is a function, so e to the x plus y minus 1, and nx is, I am just going to forget about the 1, so e to the x plus y plus x e to the x plus y. All over the nxy is the original function, which is the function beside dy. So it's x e to the x plus y plus 1. Simplifying. Now this will cancel with the e to the x that I have here. The minus sign cancels. But the minus sign also affects the other term. So I have minus 1, then minus x e to the x plus y all over x e to the x plus y plus 1. Now in the numerator, what I can do is factor out the negative sign. It's like a negative 1. So factoring out the negative sign, if you realize I will have all positive, and that's good. So having all positive, and if you're not seeing that, what I have in this bracket is the same as the denominator. I will just rearrange the numerator once I'm finished writing this. So you can see exactly that the numerator, what's in the bracket, is the same as what we have in the denominator. So I could rearrange the numerator where I can rewrite this as x e to the x plus y plus 1. So this cancels, and what I have is negative 1. So that's a x plus y, not a x plus 1. Now, it cancels to give me negative 1. So to find my integrating factor, what I am going to do, I am going to have e to the integral of the negative 1 that I have here, and with respect to x. Now, integral of 1 is x, so integral of minus 1 is minus x. So this is our integrating factor that I am going to multiply the entire differential equation by. And remember, the aim is to get it to become exact, because right now it is not exact. That is why I'm doing this. So multiplying the entire equation by e to the minus x. Now, what's going to happen? Let me just pull aside when I multiply e to the minus x times e to the x plus y. Explaining this part. Indices laws. Bases are the same, so write the base ones. And we add minus x plus x, that's gone. So we are left with just e to the y. So therefore, I will have e to the y in this position, and e to the minus x times minus y is minus y, e to the minus x. And then I have my dx plus, same scenario, e to the minus x times the e to the x plus y. I will be left with e to the y. So this will be x e to the y plus e to the minus x times 1, that's e to the minus x. So that should be a minus dy equal 0. Now, continuing further, check if this is exact. So I need to find out, when I differentiate with respect to y and x, I will be getting an exact differential equation. Now, this is a general format for the differential equation. So the first function is mxy and the second function is nxy. Now I will be tested if it's exact. So to test if it's exact, I differentiate the first function with respect to y, and differential of e to the y is e to the y. The next, e to the minus x, is held as a constant, so differentiating y, that's 1. So all I'm left with is e to the minus x. Differentiating with respect to x, I will treat e to y as a constant, so differentiating x, I will get 1, so 1 times e to the y, that's just e to the y. Differentiating e to the minus x, negative x becomes negative 1 when you differentiate it. So that's why I will have minus e to the minus x. Now this is exact. We can see that it's exactly the same. So we can proceed to our next step. Now we're going to integrate this function mxy. So I have the integral of e to the y minus y e to the minus x dx. So integrating this to treat this as a constant, so it means when I integrate e to the y, I will attach an x, it becomes x e to the y. Integrating e to the minus x and treating y as a constant, integrating this, what's going to happen is that when you integrate e to the minus x, it becomes 1 over negative 1 e to the minus x. And this is the same thing as negative 1 e to the minus x, which is minus e to the minus x. So in other words, this sign will change, so it becomes plus y e to the minus x plus our constant, which is the constant is in terms of y. So this represents our constant, which is a function of y. Now we integrate the next function, which is x e to the y plus e to the minus x. With respect to y, so integrating this, integrate e to the y will be e to the y, treating this as a constant. So I have x e to the y plus, treating all of this as a constant. So we just attach a y. So it becomes y e to the minus x plus a function of x, which is like our constant. Comparing what we have will give us the solution. I have x e to the y, and I will write it once. So I have x e to the y. Comparing again, we have the same thing here. So I have plus y e to the minus x. And there's nothing more that I can compare, so it will be equal to our constant c. Now, if I had, say, for example, plus 2 here, and over this side we don't have a 2, we would have written the 2. If this was a 2x and then I have a plus 2y here, then I will add here plus 2x plus 2y. But since we don't have any additional function being attached, this will be the solution of the differential equation. Thanks for watching. Don't forget to like and subscribe to my channel. Have a great day.